Well, go ahead to be safe. I might not need it, but that way, if you never know. And so when did you start, Brian? January, okay. So you look like a pretty young guy. You're probably going to be here a while, I assume.
We hope.
Oh, okay. All right. Okay. Well, if you see her watching Forensic Files, you need to start worrying because they have a lot of ideas on that show. Yeah. Nice meeting you. Yeah. All right. Oh, there's water. You good?
Good evening. How's the volume? Everybody hear me okay? Not too loud? Perfect. I'm Angela Mettler. I'm an administrative assistant in the president's office at South Dakota Mines. Welcome to tonight's STEAM Cafe presentation. We do this every third Tuesday, and this is a partnership with Haycamp Brewing and South Dakota Public Broadcasting. So we thank them for their support, and we thank you for your support as well. We broadcast live on Zoom, and so thank you to those of you who are attending online. At the very end, we will do a Q&A session. The presenter has also told me that he welcomes questions during the presentation as well. If you're attending online and you have a question, please type it into the chat box or the Q&A box, and we'll make sure it gets answered live, but we'll hold those particular questions until after the presentation is over. So without further ado, I'd like to introduce tonight's presenter, Dr. Matt Bunkers.
So Jesse, can you hear me okay? All right. So I'm going to start out by saying if you'll enjoy the presentation more the more beer that you drink this evening. So keep that in mind as we go along. So I'm recently retired from the National Weather Service. I worked at the National Weather Service for over 32 years, started as a student volunteer in June of '91. I wasn't eligible to retire, but there was an early opportunity to retire, and which was absolutely fabulous for me. You've heard of all kinds of things in the news, but this was the best news possible, so it's great. Since that time, I've been, and actually since the last 8 years, I've been doing part-time weather consulting as a certified consulting meteorologist. That's kind of like CSI for the weather, basically. Investigate weather as it relates to court cases, insurance cases that might involve hail damage, flooding, high winds, that sort of thing. So in this presentation, we're going to focus on supercells and tornadoes because that's what most people chase after. I'm not going to talk about rainbows or lightning or hailstorms, even though they're really interesting. So we'll focus on that. But I'm going to start with some questions. How many, I'll just ask you, how many fatalities per year do you think we have because of tornadoes, on average, in the US? Yeah, that's pretty close. Anybody else want to revise up or down? It actually turns out there's about 50 fatalities per year over the last couple decades, so tornado fatalities in the United States. Now, there are about 1,300 fatalities every year in the US due to winter driving accidents. So that's like about 25, 26 times the tornado fatalities. You're like, well, that's quite a bit different, but yet we hear a lot about tornadoes, and you don't hear about every little winter-related fatality. Now let's take that up a notch, and you have about 550,000 to 620,000 cancer deaths per year in the United States. So now all of a sudden you have this 50 tornado fatalities per year, kind of looks pretty tiny. And so I might ask you, do you think it's worth continuing to do research on tornadoes considering how few fatalities we have per year? It's food for thought. Definitely something as a researcher, which I did quite a bit with the National Weather Service, is I wondered, is this really the best way to be spending our money? Because at some point, if I issue, when I worked for the National Weather Service, I'd issue tornado warnings. And some people just aren't going to take cover. So I'm not going to come to your house, for example, and say, you got to get in the basement. There's only so much that we can do. And I think we might be there in terms of reducing the number of tornado fatalities. Otherwise, I think I have all the background information in play. Again, if you have any questions as we're going along, go ahead and ask me. I always get frustrated when I'm watching a presentation and I don't know the answer. So yes, sir.
So flood fatalities, this town obviously has experience with that. The catastrophic 72 flood. And periodically there are other flash floods, mostly here in the west. Big Thompson Canyon is another major catastrophic flood. So do those occur just occasionally, and then there's 5 times as many deaths compared to the tornadoes, or what's that frequency?
So as far as the number of flash flood fatalities per year, that's, I believe, a little bit higher than tornadoes. It might be around 60 or 70. And of course, those numbers are skewed because recall the Rapid City flood, there were 238 lives lost during the flood. The Big Thompson Canyon flood in Colorado in 1976, there were in the neighborhood again of I believe a few hundred people that lost their lives. And then there's a place out in Pennsylvania, I can't think of the name off the top of my head if anybody knows. Johnstown, yes. There's been horrific floods there over the years. So a few of these really big floods have skewed the averages, so to speak. We don't see that kind of fatality now unless you have something really, really huge, like with, for example, Hurricane Katrina caused so many flood-related fatalities. So generally the flash flood fatalities are a few here or there, and over the year, again, they add up to about 50 or 60. So again, we're gonna talk about, so again, yeah, any questions? Go ahead.
But we don't have a lot of fatalities because of you guys letting us know that a tornado's coming in your basement. I mean, isn't that part of it?
Correct. The warning system and the forecasting have gotten a lot better because in 1972, there really wasn't much in terms of the technology, like with the radars and the satellites. So it's just so much better now. And so, the fatalities might be down as low as about, what they're gonna get, because eventually it's kind of in the level of the noise. You just can't get it to zero because there are gonna be people that are just unfortunately in a bad place. So yeah, a lot of the numbers have come down because of the technology and the forecasting. Yes?
Do you have a number for deaths prior to research done on tornadoes and the technology?
Those numbers exist. I don't know off the top of my head what they are, but the trends definitely are down. So roughly in the early to mid 1990s, all of the National Weather Service offices got Doppler radars, which could not only sense just the general thunderstorm, but also the winds within thunderstorms. So then tornado detection and prediction got much better. So it's definitely decreased with certain technological advances and also substantial training advances later in the 90s at most all of the National Weather Services. But I don't have the number. I'm sure it was greater than 100. Now, but that reminds me, one of the biggest fears that we have now in terms of tornado fatalities is a tornado hits a big outdoor event. For example, Sturgis, or a baseball game in Kansas City, or a football game in the winter down in Texas where they do get December tornadoes. So that's the biggest fear right now, that something could happen. So we might be going along with 50 fatalities per year on average. Then all of a sudden we have hundreds, or maybe more than 500 if a tornado hits one of these venues. And that's why preparedness for those kind of venues is really, really important. So how many people have, just by a show of hands, have heard of the term supercell? Yes. So you either watch the Weather Channel or people on YouTube, you've heard that. I studied, most of my career I spent studying supercell thunderstorms, and they're basically thunderstorms that have an updraft that rotates. So what we can see here is down by Hermosa, It kind of looks like a barber pole, but this is rotating. And this is at a 16 times the normal speed, just so you can get the sense of the rotation. And there's actually then what's called a wall cloud down here, and eventually we'll see a little bit of a funnel. But most tornadoes are produced by supercells, and especially the strong and damaging ones. And it's because of this organized rotation, which again, where the updraft is, and then because of that, the rain and the hail fall out to the north or generally to the side of that. And that's important because if you imagine if the rain and the hail fell exactly where the updraft is, it would choke off the storm and the storm would quickly die. So most of the strong and violent tornadoes are produced by supercells. However, 10% or less of the supercells actually produce tornadoes. So even though they're really important, it's really hard to get a tornado. It's referred to as a meteorologist as the Goldilocks problem. It can't be too hot or too cold. It's got to be just right for the ingredients to come together, which is fortunate for us so we don't have tornadoes racing around everywhere. One other thing I failed to mention at the beginning is I'm going to talk about the science of storm chasing, but it's not my intent to make you all storm chasers, and that'll become evident as we go along. There's a certain amount of danger that goes along with that. So here's an animation of the supercell. Now we're going to look at an animation of tornado formation. This was south of Dodge City about 9 years ago, and we can see as before you have the same rotating updraft, and eventually we see a little bowl here, and that's where the strongest upward motion is and where there's condensation, and that's where what's known as the wall cloud develops. And so in this case, it was just kind of churning for a while, and then we realized, okay, it's getting a little bit more active. We zoomed in on this. On the north side of the roads, you see a lot of traffic going by, and there were a lot of storm chasers on this day. And it's not unusual for a storm that's going to produce a tornado to basically keep this churning going on for quite some time. This storm, this is one of the best chases I ever had. This went on to produce between 10 and 13 tornadoes, depending upon who's counting and how they're counting, because it just kept producing tornadoes for about an hour and a half or better, eventually traveling on the west side of Dodge City. One of the tornadoes did strike there. So again, attempts at funnels. Notice that again, you can see rotation. If you just see a storm that's got a low-hanging cloud that's not rotating, not much of a threat. But this clearly has a lot going on with it. Thunderstorms, especially tornadic ones like this, also suck in a lot of air. So if you note here, and maybe you can't see in the back, but you'll see dirt just kind of racing to the north into that storm because it's like a vacuum cleaner just sucking up all this air. Eventually, we see what potentially, now we're about 9 miles away from this. I'm zoomed in pretty far. Eventually, we see this probably was tornadic at that time. We just couldn't see it at the surface. And eventually, it does make a full visible funnel all the way to the ground. Then shortly after this animation ends, we get in the car and go west and then north towards Dodge City. I thought I saw a hand up. All right, so it might seem obvious what a tornado is, right? A lot of people have an idea of what a tornado is, but there's a few myths or misconceptions that I want to share with you. Number one, this is based on the definition by the American Meteorological Society. That's what the AMS stands for, not the American Medical Society. Some people confuse that. But a tornado basically is air. It's a rotating column of air. Don't have to have debris. Don't have to have condensation or cloud droplets. It's just the air. Also, it's from the base of a cumuliform cloud to the ground. Doesn't have to be a thunderstorm. Thunderstorms, or I should say cumulonimbus clouds in the tropics, aren't generally cold enough to produce lightning. To get lightning, you have to have a mixture of ice and water in the cloud. And some of the cumulonimbus clouds in the tropics that produce water spouts don't produce thunder or lightning because they're so warm. So that's the reason for that definition. Often has circulating debris or dust when over land. Not always. So you might have a tornado and you don't really see much going on at the ground. A funnel cloud may or may not be present, and it might not even be visible all the way to the ground. So again, tornado is the wind. It's not what you see in terms of the dust, debris, or clouds that are picked up. And another myth, and this is like something that's been perpetuated forever, that tornadoes magically touch down. They actually form simultaneously from the ground to the base of the cloud. And that's based on several of these observations from these Doppler radars that you've probably seen, that they've gotten really close to the storms and some of these field projects, and they can detect rotation essentially simultaneously. And so you might ask the question, well, yeah, I'll see a funnel though, and you can see the funnel kind of build down to the ground. And that's because it's slowly condensing within the tornado, the moist air from the cloud down to the ground, even though the tornado already exists at the ground, because you might sometimes see a dust swirl, but you don't see the entire funnel. So that's a myth that I want to bust. Tornadoes don't touch down, and tornadoes are the wind. All right. So you may wonder why people chase storms. For me, it's a lot to do with the science, so I can learn how the storms work and put kind of the training I get in the classroom into the field. It's also just fascinating. I love creation and all the things that go on in our environment and in our world. Several people chase storms for financial gain. You may be aware that there are tour groups that will take a few van loads around the country for a few weeks for a few thousands of dollars, all in the hopes to see a tornado. And so there are several of those groups. So if you're ever like driving around and there are a lot of storms nearby and you see either two black vans or two white vans zipping by you, that's probably a tour group of storm chasers doing that. There is also potential for financial gain by taking pictures or video, but now pretty much everybody has a cell phone that can take good pictures and good videos. So why would a TV station or somebody on social media want to buy pictures when they're just so freely available anyway? So that game's kind of played out, although some people still do that. You may have heard of this chaser called Reed Timmer, who has a tornado intercept vehicle that he likes to drive into tornadoes. The weaker ones, if you drove it into the real strong ones, I don't think it would last, but trying to get this so-called extreme footage just to sell it and to make a buck. Some people chase for personal attention through social media, whether it's Instagram or Facebook or X or anything else. Look at me, here's a tornado that I got a picture of, and it's like, it's the biggest tornado ever, and it's a mile wide, and it's violent. And I see a lot of that, and where people kind of Photoshop the heck out of the pictures and make it look like it's something that's not. I'll point out all my pictures in here are basically untouched, just what the naked eye can see, because that's what nature is. I'm not going to enhance the contrast just so it looks cooler or whatever. It's just that's what you see. And so here was whoops, back up. This was that's Dodge City right there, and so this storm was going along the west side. So some people will claim they chase storms to save lives. I will let you know that that's not true. And if you hear anybody say that, you can pull out your bullshit flag and throw it at them, because people chase storms for selfish reasons, not to save lives. It's just really not feasible. There may be research groups out there, and there are, who study storms so that we can make better predictions of tornadoes, but people going out there chasing storms aren't doing it to save lives. So if you hear anybody say that, stop them right there. All right, so a late scientist, Chuck Doswell III, is one of the pioneers of storm chasing, and he had something called I guess I better watch out here, had something called the law of danger. And basically what that says, the more often you put yourself in danger, the more likely bad things are going to happen. So judging by the age of the crowd here, most of you, maybe all of you, know who Steve Irwin was. Well, about 20 years ago, he was killed by a stingray. Well, the law of danger says if you're going to wrestle crocodiles and be with all kinds of poisonous snakes and swim with stingrays, bad things are more likely to happen. If you're a single man who likes to mess around with married women, the law of danger says the probability of you being murdered is higher than the person who doesn't do those things. And I would suggest don't do those things. That's bad. If you are a storm chaser and you drive in front of an EF5 tornado, bad things are going to happen. And in this case, 3 professional storm chasers were killed by an EF5 tornado, maybe it was rated EF3, near El Reno, Oklahoma. So they had these pods, well, roughly the diameter of that table, and they measured wind and pressure and had a camera. And their goal was to get in front of a tornado, set it down, and get out of the way. Well, because tornadoes can move erratically, they didn't get out of the way of this tornado, and they unfortunately all perished. So that's a big thing, a big theme of my presentation is safety, because that's of the utmost importance when you are storm chasing. So there are other things that happen with storm chasing. Oh, I'm ashamed to say that we actually drove over down power lines one night. We didn't see them, and we were chasing a tornado in Missouri, and lo and behold, lights kind of flickered in my pickup, and the battery ended up dying later because we drove over down power lines we didn't see. We've been hit by hailstorms, had close calls with lightning. Of course, that makes sense if you're chasing after thunderstorms, flooded roads, and numerous, like hundreds of other storm chasers out there. Roads can be completely clogged with that. Also fatigue. Day after day, if you're storm chasing, you're driving 12 hours and you get done, it's a long day. Now you have to go find a hotel, and then you get up in the morning and you do it all over again. After day, you run into some fatigue. They're also very hard to see at night, tornadoes are, and I have an example of that coming up. So here's just a couple images that show what the traffic can be like. This is on the interstate next to Oklahoma City. It was basically shut down, and I believe this was the day of the El Reno tornado where the storm chasers were killed. Here's just a rural highway, and we see you got miles and miles of storm chasers just backed up. And you might not be able to tell, but this is one of the Doppler on wheels radars. So they're out among all this trying to scan the storm. And there are unintended consequences of this. Imagine emergency services vehicles trying to do their regular normal job, firefighters and EMS, and now you have miles and miles of traffic that's blocked up. So that can be a big safety concern. I try to avoid that. Sometimes it's unavoidable if there's only one storm to chase and you have 500 storm chasers wanting to go after that. Again, the tornadoes are hard to see at night, obviously. In this case, my friend and I were in Jackson, Mississippi. We were actually headed back to the hotel, and we didn't see this tornado in real time because it was dark, it was raining heavy, but this is a video grab from my dash cam. And so we're going here, and right before we get to this light, we decide to go right because me being a South Dakota boy, I'd never eaten at the Waffle House. And my friend being from the South says, you gotta go to the Waffle House. I said, okay, we're not gonna go to Pizza Hut tonight, we'll go to the Waffle House. So we decided to turn and go west. And as we did that, the lights went out and stuff. We're like, what's going on? Well, then after we get to the Waffle House, we look at the radar and say, oh, we just missed driving into a tornado. I'll talk more about this at the end of the presentation. Here was a case where we were in Joplin, Missouri, again, chasing at night. We hadn't seen any tornadoes on the trip, so we'll try this one more time. This is a screen grab from the dash cam, but all of a sudden the lightning went off, and we're like, oh, there's a tornado in front of us. I think we will stop now and go find a hotel. So that's another reason why you don't want to chase at night. It can be very dangerous. So now we're actually going to get into the science of making a tornado. Much like baking a cake, you need certain ingredients if you're going to make a tornado. And we're going to focus on 3 steps. The first step involves getting a supercell. And this graph basically describes all of the processes in one, but we'll come back to that. So here's your supercell thunderstorm, and you get that by having wind shear in the atmosphere, which creates kind of rotating air about a horizontal axis. It gets ingested in the storm, and hence your rotating updraft. So you might be asking yourself, why is this rotation important? Well, imagine you're not stirring your beer, but if you had a cup of coffee or hot chocolate and you stir it, doesn't matter which way you stir it, you get a depression or a low spot in the middle. That's low pressure. So as this storm is spinning, it's got low pressure up in the mid-levels. Well, if it's low pressure, what's it going to do? It's going to suck up air from the ground. And that's another reason why they are so important. So that's the first step, and we'll go into detail on these. The next step is you get a downdraft where you have this rain and hail. So anybody who's been outside when it's warm and a thunderstorm approaches and starts raining, you feel a cool rush of wind on your face. That's because of the rain and hail that's falling, and it starts to evaporate, it cools the air. That's the downdraft. Well, where that cold air meets the warm air, you get this kind of horizontal circulation. Then the downdraft can further act on that and actually tilt that into the vertical. Then the final step, if you will, to make the tornado is linking these two together and stretching them and converging that. Think of like an ice skater with their hands out, and then when they pull their hands in and they spin much faster, that's really what's going on underneath a tornado. The air is converging, coming in together tightly, and then it's also being stretched, and that greatly increases the rotation. So first of all, to get a supercell, we need to get a thunderstorm. And like, again, with baking a cake, if you want to make chocolate chip cookies and you have eggs and flour, but you don't have chocolate chips, you might have an interesting cookie, but you're not going to have chocolate chip cookies. Well, for a thunderstorm, you need, wrong button. You need these three ingredients. You need moisture for the clouds, you need lift, so air that's rising, could be like flowing up the Black Hills, could be along a cold front, that sort of thing. And you need instability, and basically what that means is once air starts rising, it will continue rising, and as that happens, clouds, the air cools and clouds form. So you get your thunderstorm, you get your updraft, and then once rain starts falling, you get a downdraft. And again, if that downdraft falls into the updraft, then that kills out the storm, but if the downdraft is on the edge of the updraft, then you can kind of have this coexisting for a while. Well, in order to do that, the second thing you need for the supercell is to have wind shear. And I'm sure you're all well aware of this just based on flying and observing the clouds, but you can have directional wind shear where it might be southeast winds at the ground, southwest aloft. I mean, you can go outside and look some days and you see these low clouds just racing to the northwest, but then you look up higher and you see some cirrus or mid-level clouds and they're streaming off to the northeast. You can also have speed shear, so the wind just increases in speed with height from, say, 10 miles an hour up to 40 miles an hour. And again, that causes these kind of rotating tubes, if you will, of air in the atmosphere that the thunderstorm can then ingest into its updraft, makes it vertical, starts rotating, get the lower pressure, and you can kind of see where we're going with that. And that makes the thunderstorms last longer, and it makes them very well organized. The rotation of a thunderstorm actually increases the strength of that updraft by about double. So if it would normally be rising at 30 miles an hour, the rotation can make the air rise at 60 miles an hour because of those low pressures. So here's just a simple example that we've actually used in spotter training in the National Weather Service, illustrating wind shear. So if you have a hose here shooting straight up and there's no wind, you'll see the water just falls straight back down on it, and it basically doesn't, it affects the water, then of course it's rising, it's pushing back on that. On the one on the right, where you actually have some wind blowing from left to right, and you have wind shear, you see rising water and then falling water over here, so it's kind of has this cycle and it's not defeating itself or killing itself. So then when you have all that, you get the supercells we showed earlier with the animations. There's your rotating updraft, and the rain and hail fall out over here. The wall cloud tends to form near that updraft, and that's just a lowering of the cloud base where you have the strongest rising motion. So that's when you're looking at a cloud or a thunderstorm and you see it's kind of got a flat base, but there's some lowering, that's where the air is rising into the storm the fastest. And that's where the excitement happens if you're a storm chaser. So third, you need a downdraft, and the downdraft does a couple of things. As I mentioned earlier, you get rain and hail that falls out, it cools the air, and it causes the air then to rush out, meets the warmer air here, and you get a front that separates the warmer and the cooler air. Incidentally, these are very bad for aircraft, as you may know, because as you encounter the downdraft, we're actually on the leading edge, you have upward motion, so the plane has to decrease its lift. But then it gets past that, and it's getting pushed down by the downdraft, and it can't recover in time. And so there's been some notable accidents at Dallas over the years. It was in the Northeast at one of the air bases there as well, where there have been tragic accidents for that. Anyway, that's kind of an aside. What the downdrafts do, again, is they create this horizontal spin, which then can be pulled into the storm, and then the downdraft can further kind of bend that horizontal spin into the vertical. All right, so this kind of puts all of this together. We have the moisture, the instability, and lift, so we get a thunderstorm. You have vertical wind shear that pulls that air up away from the ground, so you get this rotation. That's really key to getting the strongest tornadoes. But again, only 10% of these or less produce tornadoes. After you have that, you have the hail and rain that's falling out over here, produces this circulation, because cold air here, warm air out ahead of the storm, and it produces the rotation. And these little white arrows are kind of pointing in the direction of that rotation. And then it gets tilted again by the downdraft underneath the storm. And if you can link these two together, you're going to get a tornado. That's step 1 and 2. So step 3 can take one of 2 different paths. The one path is, of course, to the tornado, where you have a relatively warm downdraft. So because it's warm, you can actually then cause it to rise again. Cold air is stable, doesn't like to rise. And then you get a lot of suction from the storm above, and you have the so-called ice skater effect. You pull that air in, converge, and stretch into a tornado. The other case is where the downdraft is cooler, and the storm itself might be weaker, and it can't stretch that air into the vertical. And so here's here's an animation of what I call tornado genesis failure. The storm just couldn't complete the process. We had a supercell, we had the low-level rotation, but it just couldn't complete the deal, so to speak, and produce a tornado. Here's another example, and back during the COVID days in Meade County, nothing better to do than go storm chasing. And here again, we had a supercell. Air is really being pulled into this updraft here. This is the wall cloud. Briefly, you'll see in here areas where there's a little bit of rotation, but it was a very cold kind of outflow, so the air did not want to rise. That's why I believe it failed to produce a tornado. Still fascinating nonetheless, and you can see briefly in here, you'll see a little funnel, tried, just couldn't do it. This is the norm for storms not to produce a tornado. All right, a couple more examples, still shots of tornado genesis failure, as I like to call it, because it gets really close, produces a funnel cloud. I was literally right under this after this picture, like drove right under it, and could see this whole little thing rotating, but it just couldn't close the deal. It was fairly cold. Here was a wall cloud right over Rapid City. This is at the soccer fields on the east side, so this would have been somewhere over like Skyline Drive. I've been kind of a scary location to have a tornado touch down right in town, but just couldn't finish the deal. Here is a case where we had tornado genesis complete the process, but still sometimes it can take quite a while. As you see here, here's the wall cloud, and you can tell it's really rotating. Again, this is a 16 times animation. I like to take videos and then speed them up by 16 times. You can also have your phone do that automatically. But eventually you see the funnel here, and so I would say not a tornado yet. There potentially could be one around this time. We weren't close enough to see anything at the ground, but eventually you see that the condensation will be all the way to the ground. But based on all the storm chasing that I've done, I'm convinced that most of the tornadoes last longer than what they're reported as, because I think people say, okay, now, the funnel's to the ground, so we have a tornado, but I think the tornado existed sometimes minutes before that. And I've seen evidence of that personally, where the funnel wasn't all the way down, but you got the dust swirl, you got the wind at the ground. So that's another thing to keep in mind in terms of safety, because people might be looking at this, there's no tornado yet, and they think they can drive through it, and that's, again, not a good idea. Here's that same Dodge City storm. It's the gift that keeps on giving, and it had stopped producing a tornado at this point, but it still had a lot of activity, a lot of rotation going on in here. These are all storm chasers that are, especially the ones going now north, zipping up to Dodge City. It was absolutely jam-packed with people. And then there's my storm chase partner from New Braunfels, Texas, down there, taking some pictures, and then lo and behold, there it goes again. One thing about some of these storms, after they produce a tornado, they kind of, they have the right ingredients to make a tornado, so they tend to go on producing tornado after tornado after tornado. All right, so I want to mention, we'll get a little bit, shift gears here and a little bit about forecasting and chasing if you want to do a little bit of that. Again, I'm not here to make you storm chasers though. But there's a variety of what I'll say storm chasers out there. One is just there are scientific groups. The National Severe Storms Lab out of Norman, Oklahoma is one group that's chased a lot of storms and learned a lot about tornadoes, and that's where some of the early Doppler weather radar technology was developed. Now this year there's a group out there called ICE-CHIP, which is an acronym basically studying hailstorms. My wife Heather and I were chasing north of Gillette on, was it Friday? Yeah, and about 20 vehicles came zipping by, with vans with equipment, instruments, basically trying to get into hailstorms, figure out where the hail's falling within the storm, what's the density of the hail, the various sizes, it can be oblong, it can be round, it can be knobby, and trying to just learn better where the worst hail falls in these storms and what the radar shows, because hail is big business. There's a lot of, it's $1 billion business in terms of claims every year, insurance claims, and especially big cities like Dallas, where you have a lot of people, you have a big hailstorms. It doesn't take much to get $1 billion storm come through a city like that when you got baseball-sized hail coming through. And because I do some of the forensic work, some of the consulting work, what I've learned is, and it goes both ways, people will claim they have hail, but they really didn't, but they might be close to where there was hail, so okay, they'll try to claim that they had hail. And then on the other hand, insurance companies are paying out a ton of money, and they're like, well, we don't think you had hail, we don't want to pay you. So there's this constant litigation back and forth between insurance and homeowners and businesses. Yes?
So which weather system causes the most economic damage?
Oh, that's a tough one. Well, clearly hailstorms are much worse than tornadoes. I'm not a hurricane expert, but of course, a single hurricane can be quite devastating. But if you add up the number of hailstorms versus hurricanes, and I don't have the numbers for this, but I would bet the hailstorms would win out on that, at least where we're at. Yeah. Oh, so yeah, I guess I was rambling on there a little bit, but other storm chasers, of course, meteorologists with severe weather training, and there's some non-meteorologists out there who have been chasing for decades, and they've just gained a lot of experience. Anybody with a smartphone basically can go chase people in the right place at the right time. A friend, Chris Doyle, who did a lot of driving between Rapid City and Laramie and Cheyenne and Scottsbluff, and he's seen about as many tornadoes as me, just because he's driving through an area that gets tornadoes. And again, these tour groups that are out there to make some money. So when do tornadoes happen? Well, of course, there's a tornado season. We're in the midst of ours right now, basically in the peak of our tornado season now, mid-June through late June into early July. Of course, it starts in the spring down in the south, and the tornado season shifts northward, essentially because it follows the average position of the jet stream. And you recall that we need wind shear for supercells. The jet stream gives us the wind shear, strong winds. So the tornado pattern tends to go to the north and it comes back south. So the southeast can have kind of a peak in tornado activity early in the spring and also late in the fall. And again, it's not unheard of to get tornado outbreaks down in the south, even in December, around Christmas or New Year's. Be a very bad time for that. In terms of tornadoes by time of year, just looking at the probability, again, we're at the peak right now, so about 90%, so about a 90% chance right now that there's going to be at least one tornado in the US every day for this period that we're in. This is the peak. So if you really want to see them, now's the time, now's the place. Although we've been a fairly quiet season around here locally this year. Looks like you were going to have a question?
Does this happen on every continent?
You mean tornadoes? They do happen on most every continent, sans maybe Antarctica, but South America has a kind of a tornado zone, Australia does, over in Europe, China, Japan. I mean, I've studied storms in other parts of the country, so as long as you can get the ingredients, it's just like if making a cake or chocolate chip cookies. If you can get the ingredients on top of a Mount Everest and cook them up there, well, then you could do it. That might be a little bit difficult because of the elevation, but basically where you can get the ingredients together, you can do it. And I think Alaska has had a couple even. It's less likely because they generally aren't as unstable and all that. But yeah, they can, wherever you can bring the ingredients together, you can have them. But the US has essentially the best setup because of the Rocky Mountains and the moisture from the Gulf coming together, which creates an unstable atmosphere, and the wind shear, things are kind of primed here. So we get people that visit from Australia and Europe just to chase storms in our country. So yeah. In terms of tornadoes by time of day, 5 to 6 p.m. is the peak around here, maybe 4 p.m. over by Gillette. It's what storm chasers call 6 o'clock magic, because that's when it's the most likely time to see a tornado. Essentially, by that time of day, you've heated up, you're really warm and unstable, and you're getting toward the evening, which is when the wind shear tends to increase. So where you have the most unstable time of day with the wind shear kind of intersecting, that's when you have the most likelihood of seeing a tornado. But they can happen any time of day, obviously. So in terms of forecasting, that starts with an outlook. There's a place called the Storm Prediction Center. Has anybody heard of the Storm Prediction Center? Not as many people that heard of supercells. Has anybody visited their website to see outlooks of severe storms? Okay. So that's the first step. Like if I was just giving you the very basics, I would say go to the Storm Prediction Center and then search for their outlooks. They're out for 8 days, but the first 3 days are the most detailed, and they'll give you the areas that expect hail, straight line winds, and tornadoes. That's kind of the first step. Then the next thing to do is there's so-called future radar, and I think most people that have some sort of weather app on their smartphone has something called future radar or something like that. In the National Weather Service and the operational forecasting community, there's this model called the HRR, which is the High Resolution Rapid Refresh. That's kind of like the gold standard or the Cadillac of models in the Weather Service for short-term forecasting. And so here, for example, was the future radar for this past Sunday evening at 9 p.m. And if we're around here, you recall, we did have some thunderstorms move through a line of storms, so kind of was in the right area. And then finally, and I think, I saw somebody back there, I think, had this app up. It's called Radar Scope. I don't know if it was Jade or somebody. Okay, somebody had that up. This is, again, as a chaser, you want to know where the storms are and where you are with respect to the storm. So this, here's just 3 different screen captures. This blue circle is your position. All these red dots are people who are storm chasers who have signed up to something called the Spotter Network. This doesn't mean this is all of the chasers out there, but it's some of them. So this is the infamous Dodge City storm I was telling you about. You can see all these red dots, and for each of those, it's kind of like mice. If you see one, there's like got to be a lot more. That's kind of waste these red dots are. At this point, we were right in here, so we had to come back down the road and go north. And then this was last month down in western Oklahoma. We managed to see a tornado, but we were on the north side. We had to get around it and again, navigate a lot of chasers. North of Gillette this past Friday, not many chasers there, but there was the ice chip field project that drove by us with 20 to 25 vehicles in the middle of nowhere, which is a little bit interesting. So this, again, I'll back up here. You want to have an outlook to know where the storms are going to be. Look at the radar, future radar, get an idea of maybe if we're going to have supercells like individual cells or versus a line, which generally is not favorable. And then you need an app to know where am I and where's the storm. Just here's a little bit of a safety tip. This was a storm that we were chasing near Chapman, Kansas, fairly close here. This was on I-70, screaming past it. Is there any law enforcement in here? Okay, all right. So we were speeding a little bit going around this storm because when it started to produce a tornado, we were on the backside a little bit before this time, so we actually went around on I-70 to get ahead of it. So at this particular point, we're by this hook echo right here taking this picture. You never want to go through the storm from the northwest or the north because you literally could emerge and drive right into a tornado. Not a safe thing to do. Key points to remember in terms of storm chasing and the science of that is, first of all, is safety should be your number one concern. Also, lives can be devastated by storms. I've seen, unfortunately, a few chasers, taking pictures and video, and they're like, hey, thumbs up and all that, and there's stuff getting destroyed behind them. The optics of that are not very good. Storm chasing, whether you're alone, or it's at night, or it's in rugged terrain, such as the southeastern US, is a very bad idea. Storm chasing also can be quite boring. Spend 95% of the time driving and waiting and watching. But I go with my best friend every year from New Braunfels, Texas. We meet up in Dodge City, we drive around, solve the world's problems, and if we see a tornado, that's great. So again, less than 5% of the time is actually seeing something interesting. Here's one of the most enjoyable chases that we had. This was 4 years ago already, but there were very few chasers. This was in southwestern Nebraska, but most of the chasers were down in Kansas, so there weren't many people around. It was really cool. It did some damage to some trees and power lines, and right as it was getting toward the end, it went through a feedlot, so it picked up this big area of dust. I don't know if there were any cattle hurt or not, but very picturesque tornado. So I'll take questions and answer. Actually, I guess I'm on time. I'll take questions now. I'll just let this play kind of in the background. This is a 7-minute video earlier last month in Oklahoma. You'll see chasing after the tornado and then a lot of storm chasers. And then after questions, I'll finish with one short story about that Nebraska storm. So nobody likes to ask the first question. Of course, we've already had some, but I'll take the second question to get the ball rolling.
So you said that one of the necessary elements was lift, and then you referenced the Black Hills. It's the light effect.
Well, is it supposed to be red or green? So what was the question again?
Black Hills, one of the necessary elements was lift, and that naturally happens as air moves west to east across the hills. But you don't see many tornadoes around here at all. They're very rare compared to eastern.
Yeah, tornadoes are rare around here in general, even on the plains. And there have been some notable tornadoes in the hills, the Bear Lodge Mountains up by Terry Peak. But as we saw in some of those animations and in the discussion, it's a very delicate balance to get basically that low-level rotation aligned with the upper part of the storm. And so because of the rugged terrain of the hills, that can affect that alignment, and it can disrupt that. One thing that you may notice after living around here all these years, you'll see a line of thunderstorms, for example, coming from the west, and this might have happened the last 2 times we had storms come through, and they just kind of die because the air comes down the hills. That's a downslope warming thing, and it just dies. And then about 20 miles east of here, they erupt again. And so the hills can really affect the airflow, which can mess up tornadoes. I have seen a tendency, however, over the years for tornadoes to form on the west side of the hills as the storm's just encountering them. And it might be that it's slowing down that gust front or that downdraft just enough so that the rotation at the ground is aligned with the rotation in the vertical. But we don't have enough of a sample size to really study it well, but definitely the mountainous terrain can affect tornadoes, and that's been studied also in other places like the Catskill Mountains in New York and in the southeastern US and Alabama as well. I think I had a question back there. Yes, there was a tornado that went through, and there might have been a couple, and it started southeast of Sundance, at least one of them did, and it went up right near Cement Ridge, if you're familiar where that is, and it took down a lot of trees. The nice thing about a tornado going through the Black Hills is you can really see where it went because it leaves an deniable scar and the way the trees are kind of converging towards laying towards the center of a path, it's very clear that a tornado went through that area.
What is the wind speed of a tornado when it defines?
It's in the, I don't know the number off the top of my head, but EF0 is the lowest scale or the lowest rated tornado, and I think it's in the neighborhood of about 70 miles an hour or so. You could do a quick Google search for EF scale and you would see what the bottom end of EF0 is.
So a lot of tornadoes occur in conjunction with hurricanes. The hurricanes will spawn tornadoes. That must be a whole different kind of creature.
That's a good question. So with hurricanes, they can actually spawn supercells when they come on shore, but they're called mini supercells because they're essentially about 10 to 20% of the size of that we see here. They're very tiny, and it has to do, part of it has to do with the friction. So that over the ocean, the air can move very freely because of the water. Once it hits the hurricane makes landfall, that those winds will slow down because of the land. There's the roughness of the land. Well, that then creates, if you will, a lot more wind shear, because now let's say the winds are fairly uniform at 50 miles an hour from the ground, from the ocean up, several thousand feet. Well, now all of a sudden you put the brake on the wind right at the ground once it makes landfall. So you have this huge wind shear from the ground up, a few thousand feet above the ground, and that's a perfect environment to get these hurricane spawned tornadoes from mini supercells, as we call them. Okay, you both went at the same time. Okay, you can go. She made the call. Well, okay, it's complicated. I retired on February 28th, but I'm still on the books until September 30th.
After you're fully retired, will you chase tours?
Well, yes, and I will continue because I've been chasing since, with my best friend from Texas since 2009 or 2010, roughly a week every May-ish. Sometimes it's late April, sometimes it's early June. So yeah, I will keep doing that. I've joked with my daughters, I said, I don't really, when I get too old, I don't want to go to an assisted living home. If I'm in a wheelchair, we'll have the technology at that time to know exactly where the tornado is going to be. Get me out there, put me in front of it, get out of the way, and that's how I want to go. So, but they're going to have to sign some sort of waiver. Yes. Well, it just has to do with the position of the sun, the depth of the cloud, and the amount of water droplets in the cloud. And more often than not, the greenish skies, for whatever reason, are associated with hailstorms and not necessarily tornadoes, although hail and tornadoes tend to go together. That's an area of optics I didn't study a lot, but certainly when you see that, it generally means bad things are more likely than not to happen. Yes.
Have you ever been up in that plane that they used to have?
T-28? In the School of Mines? No, I haven't. I know one of the pilots, Tom Warner, who was actually, he was in the Air Force prior to that, and that plane has since been retired. It might even be in a museum in Oklahoma now, but that flew through some storms that had updrafts as strong as 100 miles an hour. It has some pretty good measurements through some storm updrafts. It was armor plated, I think meant to withstand mostly up to golf ball size hail. It might have taken a little bit bigger. And there's a few harrowing stories of them making landings, just in the nick of time or, safely. So there was going to be an A-10 Warthog aircraft that was going to replace it, but that never made it through kind of the legal military hoops. And so that never happened. So there is no plane that the School of Mines has anymore to. Yes, there was really good data just to study the updrafts of the storm and also what's called the microphysics, which is basically the composition of ice and liquid water and water vapor within thunderstorms. So there was a lot of good data that came out of that. All right, I think I can jump to the end, or actually, I'll go back. Let's talk about this picture on slide 8. Yeah, so it was, my friend and I were chasing all day in northeastern Nebraska and didn't see anything. Couldn't get a hotel, and it was about 3 hours from near Norfolk to my sister and her husband's family farm up near Del Rapids. So we said, well, just let's go. It doesn't matter. There's a line of thunderstorms moving in. We haven't seen a tornado all day. What are the odds that we're going to see a tornado now? So started heading that way, and it's getting very dark. It's after the time of this picture. It's getting dark, but we could still see. And it's raining very heavily, and pretty soon, my friend John, who's sitting over here, says, Matt, stop backing up. Stop backing up. I'm like, I'm not backing up. I've got it in drive. I got my foot on the gas. He says, Matt, stop backing up. And I look outside. I realize we're going backwards. And I look again, and we're in drive, and my foot's on the gas. And I'm trying to talk to my friend, and he's trying to talk to me. My ears are ringing. I can't hear him. He can't hear me. And a few more seconds, and it was all done. There was still some rain, but it was done. And we looked at the radar and where we were with the storm, and we figured we must have been in a very small and weak tornado. And so even though those of us who think we're experts at storm chasing can still get into compromising situations, so that's why the 3 things I'll leave you with are safety and safety and safety. So keep that in mind if you ever go out storm chasing. So that's all I have.
Thank you, everybody, for coming tonight. I'm not sure this is working very well. Okay, there we go. So, like I said, every 3rd Tuesday we do this. So next month, the date is July 15th, and the presentation is going to be about the junior metallurgical engineering students for the past 2 years have made instruments from scratch for the Mines Band to use. So the presenters will be Dr. Katrina Donovan from Materials and Metallurgical Engineering and Dr. Haley Armstrong, who is our Director of Bands. They're going to actually bring the instruments that were made, talk about how they were made, and so you can actually see in person what was made and what was used in the performances from the band. So hope to see you on July 15th.